In this video, you will learn the basic terminology for convolutional neural network. We will talk about all this topic in great detail. If you are new to deep learning, I highly recommend you to check my other video, which is about the fundamental terminology behind neural networks, such as neurons, layers, weights, and biases. Now let's get into details about convolutional neural networks. Now let's continue with our first topic, which is kernel or filter. In convolution, both kernel and filter are the same things. On the screen, you see two different kernels. The first one is for vertical lines and the second one is for horizontal lines. What does a kernel mean? A kernel simply maps an image to a different image. If you use vertical line kernel, then the kernel will detect all the vertical lines in the original image and map the results to the new image. I have tested these two kernels on this image, which has both vertical and horizontal lines. Here you see the results. The convolutional process has been carried out on Python programming. In the first image, I have tested vertical lines, and as you can see on the pictures on the right side, the first picture contains the vertical lines because we have used a vertical kernel. But in the second image, you see the horizontal lines have been highlighted because I have used their horizontal kernel. Kernel simply maps over the image and the result contains the information about the image. In real convolutional tasks, these kernels are trained in the training phase and its weights are updated regularly. The weights are the values of the matrix you see on the screen. These two kernels are just examples for lines. The next topic we have is a channel. In the image you see a horse picture which has been divided into three channels, RGB, red, blue and green channel. In reality, images are divided into two types, RGB and grayscale. RGB images have three channels, red, blue and green. Grayscale images has only one channel. In convolution, we use kernels to get image layers. For example, in this picture, an image has been separated into 6 different channels with the help of kernels. Every channel here contains the results of a separate kernel. In convolution, for example, RGB image can be separated into 32 channels and then 32 channels can be separated into 64 channels. The number of channels depends on the task complexity and it can be changed as a hyperparameter. The next one is stride. Stride is simply the movement of the kernel. In the animation you see on the screen, the stride is equal to 1. The 3x3 kernel moves 1 pixel to the right and then 1 pixel down and 1 pixel to the right again. If we change the stride to 2, the movement will be like the following. It will move 2 pixels to the right, 2 pixels to the down and then 2 pixels to the right again. Stride is simply the movement of the kernel. The next topic is pooling. Pooling is used to decrease the image size. There are two famous pooling types, average pooling and max pooling. On the image you see an example of max pooling. In the first 4 matrix values, the maximum value is 8. That's why 8 has been taken as a value. For the next 4, maximum is 6 and then 9 and 9. In this way we have decreased the image size from 16 pixels to only 4 pixels. Usually after every convolutional layer, a pooling layer is used to decrease image size. In this way you will have a lighter neural network. The next topic is padding. Padding means to add an extra layer of the zeros around the image. In this example, one layer of zeros has been added. The dashed lines means zeros around the image. Padding is used to detect the features around the edges better. You can also check my Medium blog about the topic. I have given links in the description for both members and non-members. If you liked the video, don't forget to subscribe and like and check my other videos in this channel. I want to note that the link to all the animations have been given in the description of the video. You can check those links as well. The links means the references to the animations which are not mine. Thank you so much. See you in the next videos.